So hi folks, just a quick excursion into differentiation rules. So we're just going to quickly run through each of the rules with some really cool examples. So without wasting any more time, let's get stuck into it. So the first rule that you're familiar with is the product rule. You've actually seen this in school. Product rule. Very simple one, this. Given a function h of x, right, defined as f of x times g of x, where f of x and g of x are differentiable functions, then we want h prime of x. That is nothing more than f prime, I'm going to leave out the x's, times g plus f g prime. So notice very carefully, the rule is very simple. You differentiate one, you keep the second one constant plus, and then you keep the first one constant, differentiate the second, and there you have it. That's the product rule. So let's just try two functions. Give an example over here. Take a function h of x is equal to x e to the x. Very simple example. So h prime of x, so let's differentiate x. What is d dx of x? That's 1. Keep e to the x constant, plus keep the x constant. And what is d dx of e to the x? d dx of e to the x is e to the x. So the final answer is e to the x plus x e to the x, and can be written in a cute form, e to the x into 1 plus x. Does that make sense? It's perfect. Okay, let's try another one. So f of t equals to, say, t squared plus 1 times sine of t. Okay, so we identify your two functions. You see there's one over there, which is t squared plus 1, and then you got sine t over there. And if we want f prime of t, if we differentiate the first one, t squared plus 1, what is that? The derivative of t squared plus 1. In fact, actually show you working out here. So you say dt of t squared plus 1 is just 2t. So there we go. 2t. Keep the sine t constant. Plus or minus? Plus. Keep t squared plus 1 constant. What's the derivative of sine t? Cos t. You must know the derivatives. You must know the derivatives of your trig functions. While we're at it, let's just get a kick out of this one and say, let's go with f double prime of t. F double prime of t. Look at this. There's a product here. There's a product there. So let's just tackle the first one. So we got the derivative. There's the 2t. The derivative of 2t is just going to be 2. Keep sine t constant. Plus, keep the 2t constant. What's the derivative of sine t? Cos t. That's just the first term differentiated. Let's now focus on the second term. The derivative of t squared plus 1 we said was 2t. So there's a plus sign there. Bring it down here. So the derivative of t squared plus 1 is 2t. Keep your cos t constant, plus, because it's a product, t squared plus 1. And now, what is the derivative of cos t? Be careful here. Yes, it's minus sine t. Let's tidy up and see what happens. So 2 sine t plus 2t cos t plus, hey, interesting, 2t cos t, and there's a minus sign now. The minus and the plus becomes a minus, and you're going to go t squared plus 1 times sine t. Now this can be tidied up beautifully as well, because you have a look here. 2t cos t plus 2t cos t will give you 4t cos t. And look here as well. You have a 2 sine t. Watch here. And you have a minus sine t. So you can actually write this in a more compact way. I'm going to squeeze my answer out here so you can have a look. So 2 sine t minus sine t, watch this, is sine t. 2t cos t plus 2t cos t is 4t cos t. And the last one is minus t squared sine t. That's your final answer. Now, if you're really into the spirit of differentiation, I would challenge you to work out f triple prime of t. Okay, so that was cool. Let's go with the quotient rule. Okay, the word quotient, divide. So let's take a function h of x, and it's defined as f of x all over g of x. And we notice that g of x not equal to 0 there, because you run into problems. What's the derivative h prime of x? H prime of x, the rule says differentiate the top. I'm going to leave out the x's. It's f, keep the bottom constant, minus keep the top constant, differentiate the bottom, and all over g squared. A little bit more complicated than the product rule, but really not that complicated. Okay, let's try one. Simple one. Simple. Let's see. Example, h of x is equal to, say, x over sine x for fun. So what is h prime of x? H prime of x, he says, differentiate the top. What is d dx of x? 1. Keep the bottom constant, minus keep the top constant, differentiate the bottom all over sine squared of x. And that's your answer. Easy peasy. Okay, let's try another example. So f of x is equal to, give me an example. Okay, let's go. Ln x all over x squared plus 1. Let's keep it very simple. Ln x over x squared plus 1. I'll tell you why shortly. So we want f prime of x. F prime of x says differentiate the top. What is d dx of ln x? Come on, it's 1 over x. Keep the bottom constant, minus keep the top constant, differentiate the bottom. What's the derivative of x squared plus 1? Exactly, it's 2x all over x squared plus 1 all squared. So you could tidy things up if you want. You could pull out a 1 over x at the top, make things sweet. Because mathematics is such a beautiful, elegant subject, you can write this as x squared plus 1 minus 2x squared times ln x all over x squared plus 1 all squared. And this can be written as x squared plus 1 minus 2x squared ln x all over x into x squared plus 1 all squared. Now, the reason why I do this is that if this is a multiple choice question, you could have stopped over here and the answer is correct. But in multiple choice answers, they, meaning the examiners, including myself, they will simplify the answer. So while you may have the answer up to this point, you need to further simplify to compare and contrast your answers with the given choices. So be very, very careful when you look at multiple choice questions, especially fully simplify your answers so that they match with what's given. Okay. Okay, here's an interesting one as well. So factorization, don't forget. I'm just going to let you think about this one. If I've got f of x equals to, I don't know, let's go 27 y cubed minus 1 all over, you tell me, 3y minus 1. Now you can have a look at this very carefully, and you can say, right, I can differentiate this using the quotient rule and blah, 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 go through it a couple of pages, run out of ink, and you get the answer. But here's a hint. Look at the numerator. It's a difference of 2. So the numerator, 27y cubed minus 1, can be written as 3y minus 1 into something. What is that something? And the 3y minus 1 in the numerator will cancel the 3y minus 1 in the denominator, and then you just have to differentiate what's in that bracket. So, what's in that bracket? Cool stuff. I like that one. I like this question even better. Think about this one. G of x is equal to, you tell me, root x times f of x, where f of x is some differentiable function. I want you to calculate for me g prime of x. Now, if you have a look here, it's a product of two functions. F of x could be e to the x, could be sine x, whatever. Now, you don't go and say, let f of x equal to sine x. Oh my goodness, please don't do that. F of x is a general differentiable function, so leave it like that. So watch. Root x, f of x, differentiate the first one. Now remember, I always told you a root x, right, as x to the power half. That's very, very useful, times f of x. What's the derivative of x to the power half? The half drops up in front, x to the minus a half. The f would be there. I'm just going to leave the x out, f of x, knowing. Then it's going to be a plus sign because it's a product. Then keep the root x, which is x to the power half, as constant, and you differentiate. F of x becomes f prime of x. Now it looks okay. Now remember what this is. This is nothing more than f all over 2 root x plus root x times f prime. If you left your answer like this, no problem. But as I said, mathematics is a beautiful, elegant subject. We can take, say, the root x out if you want. You can even take the 1 over 2 root x. Watch this. 1 over 2 root x. And this becomes a beautifully 2x f prime. That's your answer. So as I said, I'll go back. If it's multiple choice, if you got to this point here, you think, hey, I got the answer. But you compare it with the choices, and it's not that. It's this over here. So make sure you fully simplify the answers. Oh, I love this blue. It's so beautiful. Okay, so let's try another one. Let's go f of x is equal to, you tell me, haha. Let's try one with the square root again, but let's go root of x plus 1 all over g squared of x. G is a differentiable function, and we also know that g of x is not equal to 0. Okay, so we want f prime of x. Now watch this. I don't like writing it as root of x. Remember I told you write x plus 1 to the power half all over g squared. Watch this. It's quotient. Differentiate the top. Differentiate the top. X plus 1 raised to the power half. Just as working on the side, what is d dx of x plus 1 raised to the power half? That is nothing more. This is linear, right? So d dx of x plus 1 is just 1. So the half drops out in front and becomes x plus 1 to the minus half. So this becomes a half x plus 1 to the minus a half, and the bottom you leave as is, g squared. Minus or plus? Minus. Keep that, x plus 1, the numerator constant. Now watch. If you're differentiating g squared, the derivative of g squared is 2g prime. G squared, 2g prime, all over g to the power 4. The g thing. G to the power 4. So let's take this. Watch and learn. Beautiful problem. Beautiful. There's a g squared there. There's a g there. So that becomes a minus x plus 1 to the power half. One of the g's will cancel, so I'll have 1g there. Take that out, throw a 2 there. Throw a g prime there, and then becomes g cubed. Now don't blink. Watch this. Beautiful. X to the minus a half. And I'm going to pull a half out. So this becomes a half. Watch. into. If I took the half there, there's left with the g minus 4. Watch. People don't like this. All over g cubed. Spend some time. Think about that very carefully. Beautiful. Gee whiz. Okay, so let's have a look at something slightly different. Okay, just slightly different. Probably repeated differentiation, or what we call higher order differentiation, but just with a slight twist. We'll be coming to something called differential equations during the course of our study of calculus. Beautiful, very powerful equations used in modeling physical phenomena in physics, engineering, mathematical biology, and cosmology, astrophysics, and the rest. Absolutely useful. Very, very powerful. So here's the thing, if I've got a function y equals to e to the k times x, and this function satisfies the following condition. Watch this. D squared y dx squared, second derivative, minus 4 dy dx plus 3y equals to 0. So in other words, we can write this as, say, y double dash minus 4y dash plus 3y equals to 0. We've got y, except, if you look carefully, there's a k there. So can we, by substituting into this equation, find a value for k? Okay. Okay. So watch this. So we've got y equals to a e to the kx. And what we want to do now is differentiate 1. So y prime, watch this. This is the chain rule. Just preempting the chain rule here. So the derivative of kx, that'll just be k, and it'll be e to the kx like this. That's very important. And now we need the second derivative. The second derivative y double dash. Again, k is a constant, so if I differentiate that, I'm going to get k squared e to the kx. And when I substitute here, what do I get? I get k squared e to the kx minus 4k e to the kx plus 3. What is y? E to the kx equals to 0. And we know that e to the kx is never 0. So we can divide through, and guess what we end up with? Hey, k squared minus 4k plus 3. How beautiful is that? Solutions to ordinary differential equations. That's coming up. Beautiful. Look forward to that section. But anyway, this is just preempting things, giving a sneak preview into what's to come. So this is now a quadratic, which we studied what, in grade 3 or something? I don't know. So that becomes k minus 3 into k minus 1 equals 0. So we have two values. We've got k equal to 3, and we have k equal to 1, and that solves the problem. How beautiful is that? So rather than say, I differentiate this function twice, boring. So I say, yeah, there we go, substitute and find the value of k. I love that question. Brilliant. Okay, so I hope you enjoyed this little video. Well, what am I saying? Let's just quickly run into the chain rule, which I think is really, really super powerful, beautiful, and elegant. Okay, so let's take a quick look into the chain rule. Now, a lot of people complain about this. It's like peeling an onion from the inside out. Will I just say that? Yeah. So chain rule basically applies to composite functions. We just saw that in the previous slide, right? For example, if I asked you y equals to e to the x, the derivative y prime is e to the x. If y is equal to e to the 2x, then we know that y prime is 2e to the 2x. And where did the 2 come from? Well, take a look here. It's a very simple, stupid way of doing it, but this is the way I do it. Peeling an onion from the inside out. Okay, so let's do that very slowly. Y equal to e to the 2x. Start off with the innermost function. The innermost function is here. You don't How would you evaluate this? If I said evaluate, watch this. Pay attention now. Got y equal to e to the 2x, and I want you to evaluate this function y at 1. So what would you do? You go to y equals to e. You'll firstly go 2 times 1 there, and then you'll raise e, so it becomes e squared. So the innermost function is that. It's 2x. So let's differentiate 2x. What is d dx? So y prime. What is d dx of 2x? Think, what is d dx of 2x? So just put that down here. I'm just right. That's d dx of 2x. Call that prime. Now, what is d dx of e to the something? What is d dx of e to the something? It's e to that something. That something turns out to be 2x. What's the derivative of 2x prime? Of course, it's 2. E to the 2x. And there's your 2. Pretty straightforward. Let's try another one. F of x equals to, I don't know, e to the sine of x? What is f prime of x? F prime of x, innermost function. Innermost function is not e, man. Yeah, that's it. Guy in the back putting your hand up. Awesome. Let's have a look at this. It's sine x. What's the derivative of sine x? It's cos x. What is the derivative of e to the something? It's e to the something. Hey, done. Let's try another one. G of x is equal to ln of x. Ln of x. Let's have a look at this. So what is g prime of x? What's the innermost function? It's the outer function. The inner function is ln x. What's the derivative of ln x? It's 1 over x. Now let's go with the outer function. What's the derivative of ln of something? The derivative of ln of something is 1 over that something. And there's the answer. Awesome! Let's try one more. Let's try one more. H of x is equal to sine squared of 3x. I find a lot of students get this wrong. Pay careful attention. Hold on to your seats. The derivative of sine squared of 3x. Now remember, this is sine of 3x all squared. You agree with that? So let's work out the derivative. Peel the onion from the inside out. What is the innermost function? Innermost function is not sine 3x. No, it's 3x. So the derivative h prime, the derivative of 3x is 3. Then the function that operates on 3x is sine. What's the derivative of sine of something? It's cos of that something. And the last bit, don't forget there's a 2 there. So it's something raised to the power 2. What is something raised to the power 2? What's the derivative of something raised to the power 2? It's 2 times that something. And so your final answer, 2 times 3 is 6 cos 3x sine 3x. Oh my goodness, how many times in my career I've seen students leave out this, so you're not sure where that cos 3x came from. Now you know. And you can write this more elegantly. I think if you agree with me, this should become 3 sine of 6x. I'll let you stay awake tonight thinking about how that's possible. Okay, so let's try something that's really involved, convoluted function here. So let's go with a function like f of x is equal to sine squared of cos of ln of x squared. That would be quite easy if you had to simplify that bit. Cos of ln of x squared. Let's just go with something like this, right? And now we want to differentiate this thing, but I want to write this very sine squared is nothing more than what? Sine of cos of ln of x squared all squared. So peel the onion from the inside out. So we're going to go f prime of x. What is the innermost function? Innermost function is not ln x squared, it's actually x squared. So what's the derivative of x squared? It's 2x. Then ln operates on x squared. So the derivative of ln of something is 1 over that something. Agreed. Then cosh, I like this color, it's a mangoish color. Mango. What's the derivative of cosh of something? Yes, it's shine of ln of x squared. And then watch this, watch this, watch this. It's what's the derivative of sine of something? These are all multiplication signs, right? That becomes cos of that something, which is cosh of ln of x squared times, I'm actually running on the screen here. And what is the derivative of something squared? It is that something 2 times. Phew, beautiful. There's no thinking involved. There is no thinking involved. And that's basically it. So it's that, and then we can write this. The x cancels there, so this becomes 2 over, oh, there's another 2 there, so that becomes 4. And you can write this 4 over x shine x squared, and then you got a cos, oh, and you got a sine similar to the other one. This is cos of cosh of ln x squared times sine of cosh of ln x squared. You can write that more elegantly because you can use the double angle formula, steal a 2 from there, put it in there, and that can be written as sine of 2 cosh ln of x squared, and that looks absolutely beautiful. But notice how cool this is, how simple, how straightforward this is. Let's try one more for fun. Right, so we give you a function, and that is, let's go, shine of ln of sine of, say, e to the x. Hoo-hoo, peel the onion from the inside out. So what is the innermost function? Innermost function is x, but e to the x of x is 1. So what is the innermost function? It's e to the x in this case. So y prime, if we differentiate e to the x, I'm going to get e to the x. And now notice times derivative sine of something is cos of that something times, watch here as well. What's the multiplication as compared to the x? They're different. A lot of students write x and the multiplication sign is the same. No, it'll lead to confusion. Okay, so we got the sign. Now we got ln operating on the sign. What is ddx of ln of something? It's 1 over that something. And finally, shine. What is ddx of shine of something? Ddx of shine of something is cosh of that something. And there's your answer. Who told you this was difficult? Yeah, it's an urban legend started somewhere on social media. Don't do math. Math is always for the clever people, the crazy people. So like this crazy guy that's doing the video right now, he's crazy, so he loves mathematics, you know. I also love hip-hop. I love skateboarding. I love dancing. I love singing. Anyway, let's do another one. Let's go back to the one that a lot of people get wrong. So let's take it very easy. Y equals to, let's do this one, simple one. Sine squared, well, let's make it sine cubed, of, what are you going to say? Ln of root x. Let's make it ln of root x. Right. Now, as I said, write this as sine of ln, but root x, I like to write it as x to the power half. And don't forget the cube on the outside. Now let's differentiate this thing in this crazy technique. So what is y prime equal to? What's the derivative of the inner function? It's the derivative of x to the power half. We know that's a half x to the minus half. Times, what's the derivative of ln of something? Hypo, man, hypo. It's 1 over that something. Then, what is the derivative of sine of something? It's cos of that something. times, and then what's the derivative of something cubed? It's 3 of that something squared. That's the answer. What's the problem? It's straightforward. We can tidy this up, and that becomes, there's a 3, there's a half, so that becomes 3 over, watch this, 3 over 2x. 3 over 2x times, now watch the beauty of this question, if you love mathematics, times. So we have a cos and we have a sine. The arguments are the same, so we can write this, firstly there's a squared there, so we can write this as sine of ln of x to the power half times, watch this, sine of 2 ln of x to the power half, all divided by 2, but instead of putting the 2 there, I'm going to put the 4 there. Watch. There's a 2 there. Where did that come from? I'll give you a little hint. Sine 2x is 2 sine x cos x. And there you have it. I hope this video is going to be helpful. Not just for tests and exams, but for understanding differentiation, the chain rule, and the like for the rest of your life. Thank you. Prof G has just left the building.